Paper 7, Practice. So question 1 is on pressure. The formula will be given to you in the exam. You just have to watch out for the units. The force is 810 units. The area is centimeters squared. But it wants the answer in newtons per meter squared, not newtons per centimeter squared. So what we're going to do is we're going to adjust 120 centimeters squared and correct it into meters squared. So here's a fact that everyone knows. There are 100 centimeters in a meter. Now, this is the conversion between centimeters and meters. It's a different conversion for centimeters squared to meters squared. What we need to do is square every part of it. If we square 100, 100 times 100 is 10,000. Square centimeters, you get centimeters squared. 1 squared is 1, and meters squared is meters squared. So this is the conversion between centimeters squared and meters squared. If I want to convert centimeters squared into meters squared, I need to divide by 10,000. So if I divide 120 by 10,000, you end up with 0.012 meters squared. And now I can answer the question. The question says work out the pressure. The pressure is 810 divided by the area, which is in meters squared, newtons per meter squared, and that's 0.012. Types into the calculator, 810 over 0.012, 67,000. Correct. Next question. So, find the highest common factor. What you do is, first of all, you need to write the numbers as products of prime factors. So it's quite nice in this question because it's already been done for you. If it hasn't been done for you, what you need to do is type in the number 3780, press equals, then press shift and the fact button, and it will appear with the answer as a product of prime factors. What we do for the HCF is we look at all the different numbers, so we have 2s, 3s, 5s and 7s, and we look for the highest power of each number provided it is common. So take a look at the 2s. We have a 2 squared in both, so we write 2 squared. We have a 3 to the power 3 in both, so we write 3 to the power 3. We have a 5 in both. And 7 is not in both, so we can't include it. Part B of this question asks for the LCM. So with the LCM, it's just almost the same definition, but not quite. It is the highest power of each different number, but it doesn't have to be common. So for example, if you take a look at the 2s, it doesn't need to be common, so you can choose 2 to the power of 3. Choose the highest power of each different number, but it doesn't have to be common. And out of the 3s, choose the highest, 3 to the power 4. Out of the 5s, they're both the same, so just choose one of them. And out of the 7s, you can write 7 this time because it doesn't have to be common, and this is the answer. Both of these questions ask you to give your answer as a product of prime factors. So we can leave our answers like this. There is no need to type it into the calculator. Next question. We have 3 people, M, L and N, and they share £420 between them in this ratio, 4 to 5 to 3. That's the first thing we're going to do. We're going to share the £420 in the ratio 4 to 5 to 3. So the total number of parts that we have is 12. If you add them together. So I'm going to divide 420 by 12 to work out one part. 420 divided by 12 is 35. This is one part. Now I can work out 4 parts, 5 parts and 3 parts. So 4 times 35 is 140. 5 times 35 is 175, and 3 times 35 is 105. And if I add all of these numbers together, they will add up to make 420. Liam then gives Ned £75. So Liam's value or amount of money is going to go down by £75 to £100, whereas Ned's is going to increase by £75 to £180. And the other chap has the same amount. Express the amount of money that Ned now has as a percentage of the £420. So when it says as a percentage, we write it first of all as a fraction, Ned out of the total, and that's the fraction. But to convert it to a percentage, you need to times by 100. Let's type that into the calculator. 180 over 420 times 100. And we copy down the calculator display, 42.857, and then you round it to the nearest whole number, 43. Next question. The diagram shows the position of 2 telephone masts A and B. Measure the bearing of B from A. So when it says from A, that means you start at the north line at A, and you go in a clockwise direction to the letter that you're interested in. You always start from A, so well, in this case, from A. So from the north line, in a clockwise direction to the letter you're interested in. When it says measure, you will use a protractor. So take your protractor, place it on the north line, as follows, and measure the angle in a clockwise direction using outside numbers, so we end up with 60 degrees. Now you can't write 60 degrees on the answer line because bearings are 3 figures, so you need to write 060. Another mast is on a bearing of 160 degrees from B. Okay, so what I'm going to do, it says from B, so I'm going to find 160 degrees from B. Line the protractor up, find 160 degrees, which is here, place a dot, which is just exactly 160, that's great, and I need to measure 4 centimeters from B. So what you do now, take your ruler, okay, start at B, align your ruler with the dot, draw a line which is exactly 4 centimeters long. So like this, up to your dot, up to 4 centimeters, in line with the dot, place a cross at the end, and this is C. Okay, to solve these inequalities, what the idea is to get X in the middle. So the first thing that we need to do is subtract 5 from every section. So if I write minus 5 from every section, we'll end up with negative 9 is less than, plus 5 and the minus 5 will cancel out, leaving 3x, and 11 taken by 5 is 6. And the next thing we need to do is to get x in the middle, so we divide it all by 3. Divide by 3, negative 3, divide by 3, x, divide by 3, 2. This is the answer that goes on the answer line. Write down the integer values that satisfy this. So if we have a look at the answer from part A, it should be fairly easy to see that the answers are negative 2, negative 1, 0, 1, and 2. 2 is included because it's less than or equal to. Negative 3 is not included because it's negative 3 is less than x. Next question. We have some information and we have to compare the distributions. Okay, so when you compare distributions, they give you usually 4 lines of working. The best way to set it out is to talk about the median, explain the median, and it's okay to write this at the start of the 4 lines so you remember. So median, explain, and then IQR, explain. And you don't have to use the IQR, you can use the range instead of the interquartile range. But what we're going to do is we're first of all going to work out the median for marshland. Okay, now it's quite easy to see that 107 is the median because the median is the middle number. Look, if you look at the way they position the numbers, you can see that 107 has 1, 2, 3, 4, 5, 6, 7 numbers before it and 7 numbers after it. It's sticking out at the end here. But if you don't like that idea, you can use the formula for median, which is n plus 1 over 2. So n is the number of data items. So the number of data items is 15 plants. 15 add 1 over 2. 15 add 1 is 16. 16 divided by 2 is 8. The median is an 8, but it is the 8th one, as long as they're in order. 1, 2, 3, 4, 5, 6, 7, 8. And if the median is the 8th one, that means the lower quartile will be the 4th one, because the lower quartile is a quarter of the way. If halfway is 8, then a quarter of the way must be 4. So the lower quartile will be the 4th one, and the upper quartile will be the 12th one. Okay. Now, another way to do this is to work out the lower quartile. You work out the middle of the numbers to the left of the median. So you cross off 87 with 107, 95 with 105, 98 with 102, and you end up with this. Okay. And the way that you work out the interquartile range is you do the upper quartile minus the lower quartile. So if we write down 119 minus 102, so 17. Now, all of this information is there. I've shown my working. You need to show how you calculate the interquartile range. You need to show that you're highlighting the numbers so the examiner knows which numbers you're referring to. Okay, so let's write some sentences. So first of all, you can see clearly that the median in marshland is greater than the median in mountain habitat. Okay, so just say that. Marshland median is greater than mountain median. It's fine to write it like that. Okay. Okay. If you want to quote the numbers, that's fine as well. 107 is greater than 85. 85. Yeah. Now, what does that mean? These are plants, heights of plants. If the median is higher in marshland, then that means that on average the plants are taller. Interquartile range, try to choose the lower one because then you can mention the word consistent in the explanation. So let's have a look. We haven't worked out the interquartile range for mountain habitat yet. So we have the lower quartile and the upper quartile. The IQR will be 99 minus 65, which is 34. So then we can say something like this. I want to say which one's less. So marshland, top marshland IQR is less than mountain IQR. Okay, and what does that mean? Well, the smaller the IQR, the more consistent the data. So, marshland plant heights are more consistent. Okay. So, the smaller the IQR, the more consistent the data, but you just have to reference it to what the question's about. Marshland plant heights, or height of marshland plants are more consistent. Anything like that is fine. And a great way to set it out is like this: median explain, IQR explain. Next question. Right. 8 to the power of a third. If you don't know what that is, you type it into the calculator. 8 to the power of 1/3. Power of a third means the cube root, which is 2. So that's 2. When you have a bracket to a power, so for letters, you times the powers together. So if you do 6 times a third, that's 2. And if you do 12 times a third, that's 4. So this is the final answer to the question. Right. If you're asked to estimate the gradient of a curve at a particular point, this is quite a skill actually. You need to find -1 on the x-axis and mark a point on the curve. Then very carefully take your ruler and line it so it's a tangent to the curve at that particular point only. So you have to take great care with this, because if the ruler's slightly off, your answer may be incorrect. So what we're going to do is going to line the ruler up, as you can see over there. Okay, get it. Place the ruler below the curve, beneath the curve, so that it's just touching at that point there and nowhere else, and then draw a very long tangent. This tangent to the curve. Okay. Now, what you then do is choose 2 points on the tangent that are easily readable. So I think this one's okay, and this one looks alright as well. Okay. So this one here is -1.510, and this one here is 0. So let's go down in 1, so -3. And now I'm going to use the formula for gradient, which is y2 minus y1 over x2 minus x1. So like this. If I label the coordinates x1, y1, and x2, y2, substitute into the formula, so you have -3, take away 10, over 0, minus 1.5. Be very careful with that one. Okay. And you can change the two negatives to a plus, or you can have a calculator to deal with it. -3, 10 over 0, minus 1.5. Okay, so I get an answer of -8.6 recurring. Okay. Now, I believe in the mark scheme, any answers between -6 and -10 were allowable. Okay, next question. Work out the size of angle ABD. Now, the first thing I notice when I look at this question is the fact that there's a chord there and a tangent. There is a rule in circle theorems which is very useful when you're trying to work out when you have a chord and a tangent, because the angle between the tangent, which is the red line, and the pink one, the chord, angle between the tangent and the chord is equal to the angle in the alternate segment. And the way this works is you look at the chord and you take each side of the chord, each end of the chord, and follow it to the edge of the circle. So start at A and go to the edge of the circle, the circumference at B, and start at D and also end up at the same point, B. Now, the angle between the tangent and the chord, which is this one here, is equal to the angle of the alternate segment. And you can figure out where it is by looking at the ends of the chord and following it to the edge of the circle. So these two angles are the same. And in this question, it asks me to work out angle ABD. Right? So I want to know what this angle is. We have a radius here as well. A radius and a tangent meet at 90 degrees. So there's a 90-degree angle here. Yep. And that means I can work out this one here by subtracting 32 from 90, which will give me 58. This one is 58. I'm going to write down a reason for my answer. So let's write this down. ADC equals 58 degrees. Okay, and the reason why is tangent meets radius at 90 degrees. next one, which is the one I'm interested in, ABD, well, I just mentioned earlier, it will be the same as angle ADC. It's also 58 degrees. Why is that? That's known as the alternate segment theorem. And there you go. So we can write 58 degrees on the answer line. Next question. Right. With this kind of Venn diagram question, the best way to deal with it is to fill in the middle section first, if you can, and work on it afterwards. So let's put 5 students have all 3. So 5 students have all 3. 5 students. 7 students have both a laptop and a tablet. Laptop and tablet. The overlap between laptop and tablet is here. That's laptop and tablet. It's where the L and T circle overlap. So in this green section, it should add up to make 7. But as you can see, there's a 5 already in there, so this has to be 2. Desktop and tablet, that's desktop and tablet, that's this section here. That has to add up to 11. So currently there's 5 in there, so this must be 6. And then 9 have desktop and laptop, that's this bit here. So currently there's 5 in there, so that has to be 4. 16 students have a tablet, that's in the T circle. All the numbers have to add up to make 16. So 5 add 6 is 11. 11 add 2 is 13, so there's another 3. 17 in this circle, 9 add 2 is 11, and we need 17, so that's 6 in there, and 19 in the desktop, so 10, so that's 4. Okay, there's also a line outside the circles, because there may be some students that don't have any of desktop, laptop, or tablet. So we know that there are 32 students altogether. If you add all of these numbers up, you end up with 30. So there's 2 outside. Now, you will be very careful with this question. This is called conditional probability. It's when it's restricted to a certain area of the Venn diagram. One of the students with both a desktop computer and laptop is chosen at random. So the first thing I'm going to do, I'm going to highlight that region on the Venn diagram. One of the students with a desktop and a laptop. That's this area here. It's where the D circle and the L circle overlap. Okay? Now I'm aware that some of the T circle is in there, but desktop and laptop, where desktop and laptop overlap is that pink section. Okay? Now, if we concentrate on that region of the Venn diagram, we know it has to be out of 9 because there's only 9 people in the bit that I've shaded. So remember, we're only looking at these 9 students because it's only one of these students that's chosen. Find the probability that this student also has a tablet. Well, out of those 9, how many of them have a tablet? You can see by looking at the T circle that 5 of those 9 have a tablet. So the answer is 5 times. Next question. Okay, this is a non-right angled triangle. That means it's not the SOHCAHTOA and it's not Pythagoras. It's either use of the sine rule or the cosine rule. So calculate the length of AC. We use the sine rule when we have 2 sides and 2 angles involved, and we use cosine when we have 3 sides and 1 angle involved. And when I say sine and cosine, I mean the formulae that are on the formula sheet for sine rule and cosine rule. So, calculate the length of AC, that's this side here. Okay. We have 2 sides and 2 angles involved, so it's clearly the sine rule. Now, the way that we deal with this is sine rule is A over sine A equals B over sine B equals C over sine C. But there is another version of the sine rule where we just write the reciprocal of all the fractions. So all the fractions upside down. Sine A over A equals sine B over B equals sine C over C. but that one is useful when we're working out an angle. We're working out a side at the moment, so we will use the version that's on the formula sheet. And the way that it works is you pick a side in the numerator and you write sine of the angle opposite in the denominator. So like this. You pick a side, so x, and in the denominator, sine of the angle which is opposite to that side. Now the only other side you can choose is 9.4, and in the denominator you write sine of the angle which is opposite to that side, so sine 123. We're trying to work out x. X is currently being divided by sine 35, and the inverse operation of divide is to times. So we can write on this side times by sine 35. Okay, let's type this into the calculator. 9.4 over sine 123, close brackets, and then times by sine 35, close brackets. Okay, 6.428. Rounded to three significant figures, that's 6.43. Copy down the majority of the display and then round it. Right, calculate the area of the triangle. Okay, now the area of a triangle is a half AB sine C. Now let's have a look at what information we've just worked out. We have just worked out that this side is 6.43, and I can easily work out this angle here as well, because angles in a triangle add up to 180. So if we work out that angle, 123 add 35 and then 180 subtract ants, so this is 22. Now when you're using the formula half AB sine C, you use two sides that sandwich the angle. So can you see that 6.43 and 9.4 sandwich angle C? But I've just worked out angle C. There's no point working out the side length AB when it was very easy to work out this missing angle, because I already have the two sides that sandwich this angle. So it's the easiest way to deal with this question is to use 6.43 and 9.4 and this angle in between. Okay, so like this. It's a half AB sine C. So it's a half times 6.428, the entire display, times the other side, which is 9.4, times sine of the angle that's sandwiched between, which is 22. We type it into the calculator. We have, okay, so we have, I need my display from before. See, this is why you copy down the calculator to display. So then you don't have to retype it again. So I need the full display. So gotta get that. Okay. That's not right. That's 35. Okay. There you go. So now we're gonna have a half times ans times 9.4 times sine 22, a half AB sine C. Have the answer 11.3188. Give your answer correct to three significant figures, 11.3. Okay, for the next question, we have to prove that the difference between the squares, so let's highlight these keywords, difference between the squares of any two consecutive odd numbers is always a multiple of 8. So we use the letter n to represent any integer, whether it's odd or even. We use 2n to represent an even number, even integer, and we use 2n minus 1 or 2n plus 1 to represent an odd number. Now the question says, prove algebraically that the difference between the squares. What I'm going to do is I'm going to divide the screen into two parts, and I'm going to answer this question using numbers on the left hand side and then algebra on the right hand side. Now you get no marks at all for doing this question, proving this question with numbers, because you're not proving, you're just showing it. So you take two numbers, two odd numbers, two consecutive odd numbers at that. For example, 3 and 5. And it says the difference between the squares, so we need to square them. So 3 squared and 5 squared. 3 squared is 9, 5 squared is 25. And then it's the difference between the squares. So if you want to work out the difference between 25 and 9, you would do something like this. 25 take away 9 is 16. Now apparently this number at the end is in the 8 times table, and of course it is. 8 times 2 is equal to 16. So that shows, not proves, that it works in this particular case. But we need to prove using algebra. And that's why the second word of this question is prove algebraically using algebra. So we take the difference between squares of any two consecutive odd numbers. So take an odd number like 2n minus 1. The next odd number will be 2 higher than that, so 2n plus 1. Then what do? We square each of these numbers. We square 2n minus 1. And we square 2n plus 1. And when you square a bracket, that means you write the bracket twice. So 2n minus 1 times 2n minus 1. And then 2n plus 1 times 2n plus 1. And you expand the brackets using whichever method you like. So 2n times 2n is 4n squared. 2n times negative 1 is negative 2n. Negative 1 times 2n is negative 2n. And negative 1 times negative 1 is positive 1. For the other bracket, 2n times 2n is 4n squared. 2n times 1 is 2n. 2n times 1 is 2n. And 1 times 1 is 1. Let's simplify. 4n squared minus 4n plus 1. And then for the second one, 4n squared plus 4n plus 1. Okay, so we're at this stage now. Okay, so what do you do next? You work out the difference. Now the difference is the one on the right hand side subtracts the one on the left hand side. So let's write it in that order. 4n squared plus 4n plus 1 minus 4n squared minus 4n plus 1. Now this is actually incorrect at the moment because you're subtracting all of this. You have to write it in brackets. And what you do now is you apply the negative to the bracket, okay, as follows. So you've got to imagine there's like an invisible minus 1 here. And what you're doing is you're timesing all of these terms by this negative 1. So negative 1 times 4n squared is negative 4n squared. Negative 1 times negative 4n is positive 4n. And negative 1 times positive 1 is negative 1. Okay? A lot of terms will cancel here. 4n squared minus 4n squared cancels. 4n add 4n is 8n. And then plus 1 minus 1 cancels. So you're left with 8n, which is clearly a multiple of 8. If you end up with, say, 24n, in another question, and you want to show that this is a multiple of 8, you just factor out an 8 like this. So the examiner can see that there's an 8 involved in the question. That's not part of this question. But if you need to show that it's a multiple of 8, but you end up with, say, 24n, then this is what you do. Okay, next question. So, probability, n beads in a bag, 6 are black and the rest are white. Heather picks at random 1 bead from the bag and does not replace it. So we have a tree diagram. We have 2 colours, black and white. This is the first selection, and the second selection will follow. Now, let's have a look at these branches of probabilities. There are n beads in the bag to begin with, so they're both out of n. There are 6 black in the bag, the rest are white. Now, let's think about this for a moment. If we have 6 tenths This is just an example. If the 6 out of 10 are black, then obviously 4 out of 10 are white. But how do you end up with this number 4? What you do is you look at the difference between 6 and 10. You do 10 take away 6, and 10 take away 6 is 4. So, to work out the number in the numerator here, you work out the difference between the denominator and the numerator. So it's n take away 6, just like we did 10 take away 6 here. We do n take away 6 on this branch, n take away 6. Now, there's some very important information here. Heather picks one bead at random and does not replace it. If she does not replace it, that means second time round, there will be one less bead in the bag. So the second set of branches will all be out of n minus 1. So they'll all be out of n minus 1 because there's one less in the bag. Okay, now let's fill in the branches. So we're at the beginning here, and we take a black one. If we take a black one, there's going to be one less black one in the bag, so there's now going to be 5 black ones in the bag. If we go back to the beginning, if we take a black one out of the bag, then there's still going to be the same number of white ones in the bag, and the number of white ones in the bag is n minus 6, so we write n minus 6 here. Okay, go back to the beginning. This time you take a white one out of the bag. If you take a white one out of the bag, then there's still the same number of black beads in the bag, which is 6. Go back to the beginning, reset. This time you take a white bead out of the bag, so there's going to be one less white bead in the bag. So previously there was n minus 6, but you're taking one out of the bag, so you're subtracting 1 from this. And when you simplify this, you end up with n minus 7. Now I have filled in the entire tree diagram so you can see how the entire tree diagram should look. Now I did too much because we're only interested in 2 white beads, so I really only needed to fill in these 2 branches. But anyway, the rest of it's there just for fun. So white, the probability that she will pick 2 white beads is a half. If you want to work out the probability of white followed by white, you times the probabilities together. So we have n minus 6 over n multiplied by n minus 7 over n minus 1. But they tell you that the probability is equal to a half, so you set it equal to a half. When you times fractions, you multiply the numerators together and you multiply the denominators together. So brackets are essential here. Okay. So when we have a fraction equal to a fraction like this, if you have a situation where you have a over b equals c over d, then a times d is equal to b times c. That's if you have a fraction equal to a fraction. So we can use that technique. Okay. Just before I use that technique, I'm going to expand the brackets. So on the top we have n squared minus 7n and minus 6n will combine to make minus 13n. And finally, negative 6 multiplied by negative 7 is positive 42. On the bottom, we have n squared minus n is equal to a half. Right, I'm going to use this technique now where I multiply diagonally. So if I times the top left by 2, so you have 2n squared minus 26n plus 84. And that's equal to 1 times n squared minus n, which is obviously n squared minus n. Quadratic should equal 0, so we'll subtract n squared from the left and add n to the left, so like this. 2n squared minus 26n add 84 minus n squared plus n. When you simplify this, you end up with n squared. 2n squared minus n squared is n squared. Minus 26n add 1n is minus 25n, and then plus 84. Okay, and this is the exam board's answer. If you want to, you can write on a show that question QED, which is Latin, quod erat demonstratum which is I have shown what I was asked to show. No extra marks, but very good. Next, sine graph. A sine graph. So here's the graph of y equals sine x. Sine graph has a maximum at 1, a minimum at -1, and some of these key points are in multiples of 90. So 0, 90, 180, 270, 360. So we can write down these coordinates fairly easily now. P is 91 along the corridor up the stairs. Q is 180, 0. Next. Here is a sketch of 3 cos 2x. Now the 3 means that it's stretched by a scale factor of 3 in the y direction. So the graph will go from +3 to -3 on the y-axis, unless of course it's also been translated up or down. So it may be stretched and go from 3 to -3, but then it may move up 1, in which case it will go from 4 to -2. But that's not the case in this example because it doesn't end in a +1 or -1, it's just a stretch. So we know for sure it's going to go from 3 to -3 on the y-axis. Also, there is a stretch in the x direction as well. When you see 2x, it's been stretched by a scale factor of 1/2, which means you get the curve, you get an entire cos graph like this in half the space. So the normal cos graph goes from 0 to 360 on the x-axis, but this one will go in half the space, so 0 to 180. Or another way of describing that is you get 2 curves in the space of 1, so you would get 2 cos graphs between 0 and 360. Because they've only shown 1 cos graph, we know that this must end at 180, because the next cos graph we draw it on will end at 360. That's not on here. So this one ends at 180. Half of 180 is 90, and half of 90 is 45. And halfway between 90 and 180 is 135. Now we can answer the questions. R must be 45, 0. And S, which is down here, is 90, -3. Next question. Sketch the graph of tan x. So what we're going to do is first of all indicate our asymptotes. So we have an asymptote at 90, at this dashed line, and an asymptote at 270. I'm going to draw a sketch of the graph, which looks like this. Tan of 0 is 0. Approaches 90 to positive infinity. After 90 it starts down here at negative infinity. Crosses at 180. Approaches the asymptote. Make sure it doesn't cross. And after this asymptote, which is a dashed line, it starts at negative infinity, and tan of 360 is 0. This kind of shape. Okay. You do not need to label the y-axis. Next question, and the last one on this paper. So completing the square. This is called completing the square. It's quite an advanced one, grade 9. So what we're going to do is we're going to factorize the first 2 terms only, but we're not going to factorize it completely. We're going to factorize so we end up with an x squared as the first term of the bracket. So if you want a simple way to remember, you take out the coefficient of x squared, because that way you'll end up with an x squared, you see, as the first term. So 2 times x squared is 2x squared, and 2 times 4x is 8x, and you have your -35 at the end. Now, inside the square bracket, I am now going to complete the square. So copy the 2, copy the -35, and complete the square. How do you complete the square? Well, you write x, and then it's half of the coefficient of x. So half of the coefficient of x is, half of 4 is 2. So it's x plus 2 in a bracket, squared. You then subtract the number in this bracket squared. 2 squared is 4, so you subtract 4. And now what we're going to do is very carefully multiply out the square bracket as follows. So 2 times the bracket is 2 times the bracket. It doesn't affect the inside of the bracket. 2 times negative 4 is negative 8. And don't forget about the negative 35 at the end. Now, when we simplify this, we end up with 2 brackets x plus 2 squared, and negative 8 take away 35 is negative 43. Okay, now we can write down our A, B, and C. A is 2, B is 2, and C is the number at the end, negative 43. If you're asked as a separate question to state the turning point is the number in the bracket with the opposite sign, and the number on the outside that's added or subtracted with the same sign. 2 does not affect the turning point. So what is the turning point? This is just a bit extra. It's the vertex of the curve. If it's a positive x squared graph, it's the bottom of the curve, the bottom of the bowl. So the bottom of the bowl is down here somewhere. Negative 2, negative 43, down here somewhere. Yeah. And also it crosses the y-axis when x is 0. So if you substitute x as 0, you end up with 0 squared, 0 times 8, so it's all 0, and negative 35. So we have this point here, negative 2, negative 43, and it's going to cross the y-axis at negative 35, which is about here somewhere. Then you can draw the curve like this. Turning point at this, that's where the bottom of the bowl is. But also it crosses here at negative 35, you see. And that's a sketch. Now, that's a bit over the top, but you quite often get these questions as part B or part C. Right, the last question of the paper. The fourth term of an arithmetic series. So fourth term is a plus 3d. It's always a plus 1 less than the term number d. So a plus 3d is 70. And then for the next one, a plus 9d is 35. We have simultaneous equations here to work out a and d. You can work out a and d quite easily by subtracting. Now I'm going to subtract, but I'm going to read it in this direction rather than rewrite the 2 equations. So a minus a cancels, bye-bye. 9d minus 3d is 6d. And 35 minus 17 is 18. Then divide both sides by 6, so d is equal to 3. Substitute into one of the equations to work out a. So if I choose the top one, so a plus 3 times 3 is equal to 17. So a plus 9 is equal to 17, and that means a is equal to 18. 8. 17 minus 9 is 8. Now, the question asks for the sum of the first 50 terms. So the formula for the sum of n terms is on the formula sheet. It's n over 2 square brackets 2a plus n minus 1d. This is from formula sheet. So we have a situation like this. N is 50, it's 50 terms. A is 8, and D is 3. So we substitute 50 over 2, square brackets, 2 times 8, or 2 brackets 8, plus, now let's concentrate on this bit, n minus 1. So n is 50, and 50 minus 1 is 49. So it's 49 times D, which is 3. Type this into the calculator. So we have 50 over 2, brackets 2 times 8 plus 49 times 3, close brackets. And this gives us a final answer of 4,075. Okay, that's the answer to the question. And rough grade boundaries for this paper. You need about 78% for a 9, 62% for an 8, 50% for a 7, 38% for a 6, 28%, for a 5, and around about 19% for a 4. Thank you.